everyone. We're going to find the Maclaurin series for f of x and also find the associated radius of convergence for f of x equals sine pi of x. Now we're going to use this formula here, our definition of Maclaurin series, and go ahead and start cranking out some derivatives. So we're going to have when, we'll start with n is 0, we're going to use f of 0, and we have sine pi of x. So when you evaluate that at x equals 0, we're going to get 0. All right, so for 1, we have f prime of 0, the first derivative. That's going to be pi cosine of pi x. Now evaluating that at x equals 0, that's going to give us pi. All right, next, so let's try 2. So our second derivative is going to equal negative pi squared sine pi of x. And if you evaluate this at x equals 0, that is 0. All right, for n equals 3, we have f triple prime of 0. That's going to equal negative pi cubed cosine pi of x. If you evaluate that at x equals 0, you're going to get negative pi cubed. And let's do some more. Let's do 4. So f, fourth derivative with 0 is going to give us pi to the 4th power times sine pi of x. At x equals 0, that gives me 0. And let's do one more. Let's do the 5th one. So f, to 5th derivative is going to equal pi to the 5th power cosine of pi x. Evaluating this at x equals 0 gives you pi to the power of 5, and then it repeats. So it's going to be a repetition thing, and I'm going to go ahead and write this all out in this form given here. So let's do that. We're going to get sine pi of x equals 0 plus pi x plus 0 minus pi cubed divided by 3 factorial x cubed plus 0 plus pi to the 5th power divided by 5 factorial, and then we have times x to the power of 5 plus dot dot dot. Now this simplifies to pi x, I'm just taking out the zeros, pi x minus pi cubed divided by 3 factorial times x cubed plus pi to the 5th power divided by 5 factorial, and then that's x to the 5th, and let's add another one based off our pattern, minus pi to the 7th power divided by 7 factorial x to the 7th power plus dot dot dot. So writing out this in summation notation, we're going to get this equals the sum, n equals 0 to infinity. Now we have the alternating signs, so this is going to be negative 1 to the nth power. We have pi here, so this is going to be pi. It's going by odd numbers. So the formula for odd numbers is 2n plus 1. And then divided by 2n plus 1 factorial. And then also for our x is also going in odd numbers. So that's going to be x to the power of 2n plus 1. And that's it. So now we have to find the associated radius of convergence. We're going to use the ratio test. So let's do that. So we're going to take the limit as n approaches infinity of a sub n plus 1 divided by a sub n, absolute value. So this is going to equal the limit as n approaches infinity. Now, I'm adding from what I had before, I'm adding n plus 1. So instead of, we had pi, we had 2n plus 1. Now, since I'm adding 1, so if I had 2n plus 1, you just add 2 here. You add that 2 to that. Or you could say 2n plus 1 plus 1. That's going to give you 2n plus 3 times x to the power of 2n plus 3 divided by 2n plus 3 factorial. Then we divide by a sub n, our original, which is the same as multiplying by the reciprocal. So we're just going to flip what we had around. 2n plus 1 factorial divided by pi to the power of 2n plus 1 times x to the power of 2n plus 1. All right, let's see what we have here. Let's write this as the limit as n approaches infinity. Now let's look at the pi. So at the pi, what we're going to get is when you have pi to the power of 2n plus 3, you have to subtract that. So it's minus 2n, 2 pi minus 1. So this is going to give you pi squared, because we have 3 minus 1. And let's look at our x's. Same thing with the x's. That's just going to be x squared. For our denominator, we can look at this and write this as 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. That's definition of factorial. So basically these two will cancel out, and we're going to be left with 2n plus 3 times 2n plus 2. Now as you take the limit, this equals 0, which is less than 1. So our radius of convergence is infinity for all x. Thank you. Have a nice day. Bye-bye.